The primary use for an API is to allow consumers to modify resources. By resources, I mean stuff in the database, so it could include creating new items, updating them, deleting them, or whatever. However, certain resources should have restricted access. We don't want one user to be able to change the password of another, for example. So that's why we protect certain resources, and we make users supply their ID and password before we allow them to access that resource. In other words, we authenticate them. Now, the difficulty in doing this with the HTTP protocol is that requests are stateless. The API doesn't know whether any two requests were from the same user or not. Now, a naive solution to this is to require the user to provide their username and password on every call to the API. Now, obviously that would be a really bad user experience though, because you'd be forever typing in your username and password. Now, there's a number of systems that have been created to allow users to supply their password just once, but then be identified in another way by the server in subsequent requests. And the current state-of-the-art system for doing this is called JSON Web Token. So there's a great article that I'll reference in the notes, which makes a good analogy about how JSON Web Tokens work. So instead of an API, imagine that you're checking into a hotel, and the JSON Web Token is like the plastic hotel security card that you get. So you can use this card to access your own room, and as well as the hotel facilities, but not anyone else's room. Now, of course, when you check out of the hotel, you give your key card back. Well, that's analogous to logging out of the API. The structure of a JWT is pretty complicated though, so let's do a quick overview of how they work. On the left side of the screen, you can see a real live JSON Web Token. So you'll notice that there are three strings included in it. There's this red one here, the purple one, and a blue one, and each is separated by a period. Now these three strings are base 64 encoded, and if you decode them, you get the header, the payload, and the signature down here. So the header is basically just meta information, and we'll refer to this a little more in a moment. Much more interesting is the payload, the second part down here. Now remember that the point of the token is to allow a user to be able to identify themselves to a stateless API. So it's the payload that is the first part in doing that. And in our implementation of a JWT, we're going to be putting the user's ID in the payload. Now, we're actually going to be using the unique ID that Mongo generates for the user document. So it's important to understand that the payload itself, and the header as well, these are not secure. So anyone can, if they've got your token, anyone can decode this base 64 here and get this information out of it. So the base 64 encoding is not secure. It doesn't provide any kind of security at all. So that's why you've got to keep in mind that the payload should not include any kind of sensitive data. So we can identify our users via their email because we make that a unique property on the model. But the reason we're going to use their ID rather than their email is for exactly that reason, because generally people don't want their email exposed. So even though a payload is all that you'd actually need to identify a user, it's not enough to authenticate a user, because someone could easily just find your ID and they could forge a token and pretend that they were you, if this is all it included. So that brings us now to the signature, and this is the key piece of how the token works. Before we explain how the signature works, we're going to need to define what a hashing algorithm is. So it's a function that will transform a string into a new string called a hash. So what you can see on the screen now is an online tool for generating hashes. So if we type in hello world, then you'll see what the hash of that looks like down the bottom here. Now there are many different kinds of hashes, hashing algorithms that you can use. The one that we're using here right now is SHA-256. That's just a really common one that's commonly used by JSON Web Token, but there are many different kinds that you could use. Now, the most important property of a hash is that obviously you can take the input string and then identify the output string. But you can't do it the other way around. So if I just gave you this hash here, even if I gave you the hashing algorithm, you could not derive the input string just by looking at the output string. So it's mathematically essentially impossible to do that. So coming back to the JSON Web Token now, let's look at the signature part again. So as you can see, it's a function of some sort, and what's passed into the function firstly is a base64 encoded header concatenated with a base64 encoded payload. So in other words, the signature function takes this whole piece in. And the other part to the function that's passed in is this bit here, your 256-bit secret. So actually the secret can be an arbitrary piece of data, an arbitrary string. The important thing is that only the server knows the secret. So we'll come back to an explanation of why that's important in just a moment. Before we do, let's just think about how this token gets used to actually authenticate you on a real API. So firstly, the server would receive this token. Actually, before we get to that, what's important to understand is that when the server generates the token, it actually stores the token as well alongside on the user model. So when it receives the token, what it's going to do is it's going to decode the base64, and from that it's going to get the ID from the payload. And it uses this to actually look up the user that this token is meant to apply to. So let's just say a user had this ID here. It can do a database query looking for the user with that ID. It gets that user back, and then what it does is it compares the token that's stored with the token that's been supplied. Now, if they're a perfect match, then we authenticate the request that this token came in on. If they're not a match, then obviously they will not be authenticated, because it tells us that either an old token was used, or perhaps somebody is trying to be naughty and they've attempted to forge a token. So with that understanding, perhaps now we can understand how the signature works, or the point of the signature. So let's imagine that we were trying to forge a token. How would we do it? Well, firstly, the hashing function that gets used here, anyone can figure out what that is, because they just have to look at the header, and it tells you exactly what type of algorithm is being used. So, SHA-256 essentially. So that's easy to find out. It's also easy to find out this piece, because anyone can take the header and the payload, and they can, for example, that if they found your user ID somewhere, then they could take that bit of information, generate a header, encode it in base64, and they've got that piece as well. But the last piece, the secret down here, that's the piece that they don't have, and this is why it is secure. Because the secret is not public information. There's no way anyone can get this. Therefore, remember that with a hashing algorithm, if you didn't have the secret, the outputted hash is not going to be the same. And since they don't know that secret, there's no way that they could generate a hash that's exactly the same. So the process of doing this, in other words, adding an extra piece of secret data to a hash, that process is called salting. And it basically makes the token impenetrable, because if they got another token, they can't take the hash of that one and reverse engineer to figure out what the secret is. It's mathematically impossible. So that's why the token is considered secure. Okay, so now you should have at least a rough understanding of how the token works. So the final question is, how do we actually transmit this token between the server and the client? How is it implemented on our server? So normally a token is added to the header of an HTTP request. So the first request it gets added to, well, it's actually the response to the request coming from the client to the server when the user is first providing their credentials. So in other words, when they try and log in, If the credentials are valid, then we send back the token in the header of that response. Now this is quite easy to do with Express. So imagine we have a function here to generate a token for that particular user. Then all we need to do is in our response, we can just attach a header. When the client then sends the token back, the server is able to authenticate you by passing the token from the header. And as we said, it's able to then look up the user based on that token, and if the token matches the one that's stored, then the user is authenticated. So it's not actually that hard to implement, so long as you have a basic understanding of how it works. Okay, so that's really the fundamentals of JSON Web Tokens. Don't worry if you didn't follow every part of that, because over the next few videos we're going to be implementing this, and through that process I'm sure you're going to become an expert on JSON Web Tokens.